Hi there. In this video we're going to take a look at the sine curve and its derivative. And before we actually go into the analytical approach to this, actually calculating the derivative, I want to make sure that you get an intuitive feel of what the derivative of sine actually is. So here I have a sine curve, and I have a tangent line to this curve at some random point x. Now this random point in this instant happens to be 1.29 radians. So as I move my x value, you can see my tangent line changing. And in fact, let's go to a well-known angle here, 1.57. You should recognize this as pi over 2. And you can see, well, first of all, the sine of pi over 2 is 1. You can see that right here. But more importantly, the slope of the tangent line, the rate of change of this curve, appears to be 0. The slope of this tangent line is 0 at pi over 2. Okay, if I move this back to 0, you can see that I now have a slope of 1. Okay, my point is at 0, my slope is 1. Okay, so let's try to plot what the slope of this tangent line actually is doing. Okay, here is the x-coordinate, here is the corresponding slope. So what I'm going to do is I'm going to highlight both of these, and I'm going to plot those as an xy coordinate. Okay, so you can see this point right here. Hopefully you can see that. As I move x to the right, you can see that point is tracing out the slope of that tangent line. In fact, at 1.57, you can see that point is at 0. As I move further to the right, you'll notice that the slope of this line went negative and the point went negative. As I go further to the right, you can see that the slope of the line is getting closer to -1 until we reach pi. Once we reach pi units, let me try to get there. There we go. That's pretty close. Once we get to pi units, you'll notice that the slope of this line is -1, and this point is down here at -1. Okay, well, you could probably guess what this is going to do. It's going to come back up, and now this trace is starting to look familiar. Okay, in fact, it kind of looks like a shifted sine curve, doesn't it? Well, if I come back here and get a better idea, a more full picture of what's going on here, it kind of looks like a cosine curve. Okay, I've drawn a cosine curve. Here it is. A little bit better picture. So the green line is a cosine curve. The yellow ball represents the height of the yellow ball represents the slope of this line right here. So try to make the connection. I really think this is an important part of understanding what a derivative is. As this point gets close to pi over 2, notice what the slope of the red line is getting close to. It's getting close to 0, which is exactly where the yellow ball is heading towards. And as soon as we get to the right of pi over 2, the slope of my line becomes negative, as well as my ball. Okay, jumping all the way back over here to 0, you'll see that the slope of my line is 1, and my yellow ball is up there at 1. So I think that's really cool to see the connection between the sine curve and the cosine curve describing its derivative. Okay, so let's go ahead and look at this analytically. Okay, so how would you find the derivative of this? Well, we don't have any rules. We can't really use power rule on this. We can't use any of the basic differentiation techniques that we learned in the previous videos. So we have to rely on the definition of a derivative. And let's get started on that. So we have the limit as h goes to 0. And f of x plus h is the sine of x plus h. Okay, minus f of x, which is just the sine of x. And of course this is all over h. Alright, well, if you try to plug in 0 here, you'll notice that you'll get 0 in the numerator, you'll get 0 in the denominator, and we know that by now that's our indeterminate form, which doesn't help us one way or the other. So I have to start to manipulate my expression to hopefully get it to something that I can evaluate. And I'm going to use an identity from trigonometry, and I'm going to expand the sign of x plus h, and that expands to the following. Okay, there you go. This is just a sum formula from a first-year trigonometry course. Maybe you learned it last year in pre-calculus. Okay, and then minus, don't forget this, minus the sine of x and all over h. Okay, well now what? Well, we still can't use direct substitution. We still get 0 over 0. So what can we do? Well, if you look at this term here and you look at this term here, they have something in common. They both have a sine of x. So let's see what happens if I factor a sine of x out. Factor this sine of x out, and I'm left over with a cosine of h from that term. And I'm left over with a negative 1 from this term. Okay, and then don't forget this guy right here. I'm just going to add him to the end. Okay, and all over h. Okay, so now if I look very carefully at this, I notice that my numerator, I really have what I call a disguised binomial. I really have two terms up top. Notice that this is a product right here, so we can really consider this as, you know, one great big term. And this is another term right here. So it's like a binomial. It's going to behave that way. Well, what happens if you divide a binomial by something? Well, you have to make sure that you divide into both terms in the numerator. So I'm going to just rewrite this, making sure that I divide each term by h. Apologize for my handwriting. I know it's not the best, but this little notepad I have I'm not used to it yet. Just put it that way. Okay, here we go. Well, hopefully some things are starting to take shape, and I realize I just made a mistake here. That shouldn't be an h, it should be an x. Okay, well, some of you may start to recognize some of these expressions that are popping out. If you look over here, it looks like I have a sine of h over h, and I know what that limit is if h goes to 0. Also, this guy looks familiar, only it would be better if this was 1 minus cosine instead of cosine minus 1. Well, we can deal with that. We can just factor a negative 1 out. In fact, I can just cheat and do that right now. I can pull a negative 1 out, making that negative and that positive. Okay, so now I'm going to rewrite this one more time, and we get the following. We get the limit. Now that didn't come out very nice, did it? We get the limit as h goes to 0. Okay, I'm going to rewrite this in a particular way so that it's clear what we're dealing with here. I have 1 minus cosine of h over h. Now, if it helps to see you that this is really the same thing, if you need to put that 1 down there, this is really the same thing as this. Okay, over here I'm going to do something similar. I'm going to isolate that, and I have a cosine over 1 over here. So pretty clear that this is the same thing as this up here. Okay, well, what do we have here? We have the limit of a sum, and I know from my study on limits that if I want to find the limit of a sum, all I need to do is find the limit of each thing in the sum and then add those limits together. So let's go ahead and break this up. I have the limit as h goes to 0 of the negative sine of x. Now watch what I do. I'm actually going to break this up as well, because I know that the limit of a product is the same as the product of the limits. Okay, so all I did was I said, instead of taking the limit of this product here, I broke it up and I'm finding the limit of each object in the product, and then I'm going to multiply the limits together. Well, I'm going to do the same thing over here. This is the limit as h goes to 0 of the sine of h over h. We know what that is. Times the limit as h goes to 0 of cosine. All right, well, all that's left to do is evaluate these limits, and we're done. Well, what do you want to start with? Let's start with, well, let's just start with the first thing here. Okay, what is this limit right here? What do you plug 0 in? Do you plug it in for x or h? Well, since h is going to 0, we want to plug it in for h, but there are no h's there. So effectively, since we can't plug 0 in for h, this limit is just negative sine of x. Okay, times whatever this limit is. Well, we know this limit from a previous problem, and we know that that limit is 0 plus. That should look familiar to you. We know that that limit is 1. And again, there's nothing to plug 0 into in this problem. You don't plug it into x. Remember, we're letting h go to 0 and not x. So that limit is just the cosine of x. Okay, well, this is clearly 0, and 1 times cosine is cosine. So we know that this limit is equal to the cosine of x. I think that's really cool. I think it's even cooler when you consider the graph and the connection between the cosine curve and the sine curve. I hope that made sense, and I hope you like it as much as I did. See you around.